And all right, perfect. Let's just delve into it. As I said, I'm just gonna give you guys like a couple of minutes. Hopefully, you're able to see the whole question. If you're not, just let me know. I'm gonna give you guys like a minute or two to like just read the question yourself, and after that, I will explain it conceptually, and then we'll go from there. Yeah, let me know when you guys are done reading the question. Everyone's done reading the question or done? All right, perfect. So now I'm just gonna like since most of the people are done, I'm just gonna like explain the question conceptually. So what the question is saying essentially that we are given a 2D array which is of type integer. So let's just call it int star a as an array. Oh, sorry, double pointer. So it would be int double pointer a as an array. And what this array is just a 2D array. And our task is to create another array which is also 2D and triple the columns. So for example, the original array is something like this, right? Let's say this. Boom, boom. So since it's a double pointer, a double pointer can point to a pointer only, right? So it will point to an array of integer pointers. So it will look something like this. And then, so these are like row one, row two, row three, right? Does that make sense so far? But actually, let me do this one better. Ouch. Okay, so this would be row zero, row one, and row two respectively, and the length of this would be just three, right? And what is happening is like this original array is now through this pointer is pointing to an integer array of size something, right? So for the sake of simplicity, let's just make the size of two, right? Because we want to triple it. So this original array is something like this. It's pointing to two integers. Let's just say 0, 1. This is also pointing to an integer array of size 2. Let's call it 1, 2. And this is also pointing to an integer array of size 2. And the values are 3 and 2. Doesn't really matter. We don't care about the values so far. And then the columns will be column 0, column 1, column 0, column 1, column 0, column 1. Uh, does anyone have any questions so far? Because I really don't want to like leave anyone behind. Okay, perfect. So now what we want to do is this is like the original array that has been passed to our function, right? So what we want to do is we want to triple the size of this. So what we want to do is instead of the columns, we want to times it by 3, right? So the size of the columns is now, so size of column now is 2, right? What we want to do is we want to create a copy of this array and we want to just like triple the size, right? So it'd be like 2 times 3 essentially, right? Does that make sense? So the new array, let's just call it int star new would look something like this. So it will be this. Since it's a double pointer, it will point to an array of integer pointers, and it will look something like this, boom, boom, boom. And since we want to triple the size, so this is row 0, row 1 and row 2. Since we want to triple the size of the columns, it now would look something like 2 times 3 is 6, right? So it will look like 0, 1, 2, 3. Or so we like column 0, column 1, column 2, column 3, column 4, and then column 5. And the size of this is 6. So that's what we want to do essentially, right? Does that make sense so far? So if we scroll back up, the question says for part A, it says, what is the fix for the line of code for point A? This one is simple, so you don't need to write out the whole solution, but just in your own words, just like explain what is wrong here. So as you can see in the point A, you see the dash dash point A. I can really draw on the photo, but hopefully you're able to see like the point A. So what we want to do is we're creating a new copy of this array, but the problem is I am tripling the size of the rows. But the question says you don't have to triple the size of the rows, right? You only have to triple the size of the columns. So the easy fix for this is for part A is you can just say we are tripling the size of rows by 3 by times 3. Uh, we don't need to do that. We don't need to triple the rows, but the columns. So just remove times 3 from that line. Does that make sense so far? That's pretty straightforward, just because we're not tripling the size, right? All right. So now that's the answer for part A. Now for part B, it says why is the line of code for point B incorrect conceptually. So for okay, part B. So the problem here is what we're doing is we're overriding the rows, right? But I mean, sorry, we're copying the rows, but what we want to really copy is the columns or the values in the column itself, right? So if we override the rows, it would now, so for example, we don't need to override these values, right? We need to, or sorry, copy, my bad, copy, not override. We don't need to like copy these values. We need to copy the values from this column to these columns, right? Does that make sense? So that's like the answer. Like, hey, what we're doing is we're assigning like we're reassigning the pointer in that, and then we don't really need to do that. We need to like assign the copies, right? So this is what we need to do, something like this. So this size, and then we need to copy the values in the columns. And 3 to blah 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 blah. Did that make sense? That one is like pretty obvious from part A, or like from the question itself, because the question says we need to copy the values in the columns, not in the rows. So that's part A. We can just say we are copying row values, but we need to copy column values. I hope that was pretty intuitive from the question itself. Uh, any questions on that one? Hopefully not. Perfect. All right. All right. So now let's go to part C. Write 2 lines of code to replace this 1 line of code so that the function will work as planned, right? So so the function is wrong, as in like it's copying the row values. The question is now asking us, how would you fix this? How would you copy the values in the columns, right? So for that, it's pretty simple. is just would be like a nested loop kind of thing. So for example, our function is just is doing this, right? So for int r equals to 0, r is smaller than rows, and then this rows has been passed to the function itself, so we don't need to worry about that. You can just say r plus plus, right? And since we want to copy the values in the columns, we would have to run a nested loop, right? So we can just say for int c equals to 0, c is smaller than columns, c plus plus, right? And then we can just say our new array at the position of r at the position of column catches the value from our old array, which is just array from r to c. So these two lines are the solution, and how it will look like is like we have this row, and these are the columns, right? So let's do one dry run so that way you can better understand it. So for example, r starts from 0, right? So r starts from position this, which is position number 0. And for each iteration of r, I have a nested loop that starts also from 0 and goes till the length of column, which is like 2, right? Or goes till 0 and 1, right? So for each iteration of I, go here and then copy the value in my new array at position r, which is 0, at position column, which is 0, right? Now, this is only the first iteration inside my J loop, inside my nested loop, sorry. And then the second iteration would be r equals to 0, column is equals to 1, and then copy the values. So it would do here, it would do here, and then my C variable inside the nested loop will reach 2, and this does not satisfy this condition, right? Because 2 is bigger than now columns, right? So it will just end, and then row will now from 0 it will become 1, and we will just repeat the process in this part again. That makes sense. If you have any questions, please let me know. Questions? No questions? No questions. All right, perfect. So yeah, that's the first question. Also, I am probably gonna post all these like pictures and notes on my GitHub, and I will put the link on the in the description for the video so that way you can like look at it. Uh, but yeah. All right, so that was question number one. Now let's move on to question number two. This is a really good question. I will give you guys a couple of minutes to read this question on your own, and then I will explain it. So let me know when you guys are done reading it. Just let me know if you guys are done reading it. I can explain it then conceptually. Done. All right. Does anyone need more time? No? All right, perfect. So now let me just explain the question conceptually and then like I'll draw like a small diagram and then we'll do the coding part. All right. So what the question is saying that we are given so we have a struct called account. I'm just gonna call it account, but it's called account underscore t, and it has some members. So if the members are character name, which is just a character array, a double amount, and then we have an integer ID, right? So these three are the members of this struct. What the question is asking us, we are given a function called merge accounts, and in this function, the parameters are account one and account two, meaning these are the two accounts that we have, right? Our purpose is to merge these two accounts into one account. So for example, let's say we have account one here like this. This is A1 and this is A2 as an account one and account two. It has three fields, right? It has a name, it has an ID, and then it has an amount. So it has a name, it has an amount, and it has an ID, it has a name, amount, and then my ID. So our purpose is to merge these two accounts into just one singular account. So we will create this box as in like M account, as in like merged account. And then the name would be, so for example, if the name for this was Jim and the name for this was like Tim, the name for this would be Jim space and space Tim, right? And the amount would be the 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 addition of this amount and the addition of this amount. So for example, the amount was like 50,000 here. Oh, 50,000, and the amount was also like 50,000 here. Our we will plus this and it would be like 100K, right? And the ID, for the ID part, it just says we don't really need to do anything crazy with the ID. This new account will just catch the ID of this box, which is of the ID of account number two, right? Did that make sense? Perfect. Now let's just call it, I'm gonna use abbreviations, but just to like, just to save some time. But when you're in the FE, when you're in your quizzes, in your exams, please make sure to use the whole, like the whole names. So, okay, I'm just gonna call it like as in I'm just gonna call account as an ACC, and then star, let's just call it merge A as in merge account, and it will take in two parameters or two arguments, sorry. Yeah, two parameters, whatever. We'll call it AAAC as in A1 and then account 2, right? So let's do the easy part first. So the easy part is copying the amount and then copying the ID. For this, the name is not, well, it's not the straightforward because first we need to like create, since it's a dynamic array, we need to create the space for this array and then copy the elements, right? So let's do the easy part first, right? So let's just do this. So we call it new account equals to malloc size of an account, right? So we have created this box. We have only created this box. We have not filled any values. We're just, the first step is first, created the box. Now we will fill in the values and we will use dereferencing, right? So because this is a pointer essentially. New, sorry, it would be, yeah, account star new, like that. Sorry. Uh Now new arrow amount is equals to catches the addition value, right? So it will be A1 arrow amount plus A2 arrow amount, right? Did that make sense so far? That's the easy part, right? This box is just catching the addition values of like this, and we're dereferencing. The arrow is the dereferencing part. Now we assign the ID, which is since it says in the function that the new account will catch the original ID of account two, so we can just say new A, this would be A here, arrow ID equals to A2 arrow ID, right? It's pretty easy. Now for the not the hard part, but the part that takes a little bit more time, is just like now we need to fill in the name part, right? We need to fill in the string. So first things first, let's create the space. So it would be, let's just say int length is equals to, uh, it would be string length of, sorry, why am I using malloc? String length of account one arrow name plus account two arrow name and then plus six. And why am I doing six is because we want to separate these. So we want to, okay, so let's say the names are Jim. We want to create a space, then put in an and, create a space, and then put in a Tim, right? So the string length of this is five. And the reason I'm doing six is for the null terminator, okay? So do we need to state the type of, do we need to state the type of variable it is? Uh, which part? That was for a counter. Like here? Initially I messed up. Yeah, but yeah, that's what you like had to do. But I messed up in the beginning. Yeah, sorry about that. Uh, so everyone understood that why am I doing the string length of this plus six is because and because space also counts as a valid uh like the empty space here. Oh my goodness. The empty space here will also count as one, right? This will also count as one, and then and is one, one, one. So it's just one plus one plus one plus one plus one, which is five, and then plus one extra for the null terminator, right? Did that part make sense so far? Anyone have any questions? Perfect, perfect, perfect. Nice, nice. This is the tricky part. Now, okay, now what we have done is we have we have created the space for this character array. Now we need to fill in, right? We need to fill in the values, right? So the first things first, I will use the string copy function. So I'll just do string copy. So the string copy function takes in two arguments, the destination and the source, right? So our destination is the new account. So it'll be new a arrow name. This is our destination. And the source I want to copy the name from is account one arrow name. So now we have Jim here. We have Jim here, right? So now you guys might be thinking, well, if I do string copy again, then it would just, if I do string copy and then put an and, it would just replace Jim and put in an and here, right? So we won't use string copy. We will use the function called string cat, which is like, it will just, so what it would do is instead of like overriding the values, let me redraw this. So it will be Jim. So if we use string cat, it will add in the values after Jim. It won't like override it. So that's the whole purpose of a string cat function, which is in the string.h library, right? So now I will use strcat, right? Again, this function also takes in two arguments, the destination and what is the source. So the destination is new a arrow name and the source is now Jim and, right, and Tim. So what I want to do is I want to do this, leave a space and leave a space and, right. So I have in my this array I have Jim space and space. Now again I want to copy Tim, which is Tim isn't like the name of account number two, right? So again I will just call in my string cat function, string cat where, which is the destination, new arrow name. And what I want to copy is A2, account 2, arrow name, right? And at the end, we will just return the merged account. So it'll be new A. And we will just end our function. All right. Any questions on that one so far? Well, this is the end of that question. We would not be expecting. Oh no 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 no. Like I think it no. You do not have to write it. I'm just wondering if it says in the question somewhere. Yeah, you don't have to write it. It's kind of like assume that they're already there. So for example, this is probably a dumb question, but how could we convey like this? Yeah. So like you can just say like you mean like how do I tell the person who's grading that I have left some space? Is that what the question is? Okay, perfect. Yeah, so you can just say like you can do boom and boom. Yeah, it's completely yeah, but yeah, it's completely acceptable. I mean, the graders they're like, they're even if you okay, I shouldn't be saying this, but even if you did not leave the space, they're kind of only gonna like the graders are good people, man. They want to give you points. They want you to pass the FE and then move on. So even if you did not leave space and they can clearly see that, hey, well, this person knew what they were doing, they will give you full points. But if you really want to be sure and you're like really paranoid, you can follow this method, right? And then the second method would be just leaving an obvious space, would be like and like this, something like that. So both are valid. Yeah. Did that make sense? Did that answer every question? Okay, if we just want to make sure. Yeah, yeah, yeah. No, graders are like cool people, man. They want to give you points. I also had one more question before that. Oh, the libraries question. Yeah, you don't have to write like you don't. You're saying like the this part, right? Hashtag include stdio. Yeah, yeah. You don't have to write this because this is like only this is assumed already that when you with the main function and all that you already have this. But again, if you're paranoid, you can just leave a small comment saying in before solving the question, or like you can just include something like include string.h if you're paranoid, that is. But you don't have to do this. But if you're again you want to be like, oh man, I don't really want to like risk anything, obviously, better safe than sorry. So hopefully everyone understood that question. Let me know if my pace is on par on par with you guys, or do you want me to like slow it down even further, or like just let me know. Is it okay? Do you prefer this pace, or do you want to slow down a little bit more? This is good. Perfect. 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 All right. All right. Yeah. Oh, I didn't mean to do that. All right. So we have covered question one, question two. Now we have to cover question number three. This will throw you off. Okay, this question is like it's like a very, like on the I would rate this question on the tougher side. So this kind of question is kind of meant to like throw you off. I'm gonna take my sweet, sweet, sweet time explaining this question because I think if you understand this question very well, you are good for the DMA part. Obviously, you need to practice more, but if you really understand the question and you can visualize it, I think you're solid for the DMA part. So just gonna give you guys 2 minutes and then read the question on your own and let me know. Uh, yeah, let me know. Anyone, anyone else need some more time? Because this is a big question. I expect you guys to take your time. Uh, all right, so I can like start solving, or all right. So what the question is asking us, we are given these two structs, right? And these structs are nested, right? So for example, we have a struct called string type, as you can see. So we have a struct, let's call it string type, and then we have a struct, let's call it employee, right? E as an employee. And this is a nested struct, as in this struct, the employee struct has in two fields, right? It has a string type field, star ename. So this would be this is essentially like pointing to this struct kind of thingy. And then it has a double salary, right? So this is for following the concept of a nested struct. So what we need to do is we first need to create an array of type employees, right? So let's just do three. Let me redraw this. First thing is first, we need to create an array of type E, right? So each index would have two members, string star ename, and a double called salary. Let's just call it sal. And what we need to do is we need to go to each and every index. So this is of type employee, fill in the salary, create this memory, create this memory, and then fill in the name and the length of the name of the employee, right? So this is what essentially is asking us. So let's visualize this. Let's say you have a company, like you own a company and you wanna keep a list of all the employees that work under you, right? So and then you wanna know their name, you wanna know and how much they make, right? So that's essentially what it uh entails, this question entails. So like you own a you own a business, you have a list of employees, you want to know their names, you want to know their salary. And how will we do that? As you can see in the function parameters, we have char, we have character names, which is a 2D array that has been passed to the function. We have a double salaries, which has been also, which is essentially a list of salaries. And then we have an EMP count, which is the number of employees your company has, right? Did that explanation made sense so far? If anyone have any questions, please let me know because this is a really in-depth kind of question. So far, so good? Perfect, perfect. Okay. So let's just copy the function, right? So I'm just gonna use abbreviations again for the sake of time. So let's just call it EMP star uh create E create employees, and it would take it has three parameters, which is char name, char n 50. Also in C, you only have to mention the size of the column. You don't need to mention the size of the row. You can, but you don't really have to. And then it would be a double salary. Let's just call it sal, and then int e count, right? Okay, does anyone have any questions for the function parameter thingy? Like why are the function parameters a 2D array of names and the salary? Is because they're being passed to the function, and this list, like we are gonna copy the names from here to here, right? So what I'm gonna do is, so this is eventually a list of a 2D array of characters, and then we're gonna copy the names from here to here, and then we're gonna copy the names from here to here. That makes sense? Okay, I'm just gonna assume that it made sense. And this is essentially represents like how many employees your company will have. Questions, guys? No? All right, all right, all right. So everyone understood, hopefully. So first things first, now I'm gonna first things first, I need to create an array of employees, right? I need to create this empty space first. Wait, could you explain one more time why is it 2D array? Which one? The name, this one, or the this one, right? This one, right? Okay. So look, it's a 2D array because I will create an array of employees, right? Right? So I will have multiple names for my employees, and a 2D array is just like this. So at index one, we have a string of name, and index zero, we have, I mean, index zero, we have a string of name, we have index zero, we have a string of name, and in index two, we have a string of name. What we're gonna do is we're gonna go to each index, right? And then copy this string name all the way to employee number one, right? Again, I'm gonna copy. So this is I fill the value for EM employee one and his name and their name, sorry. And then I'm gonna do the same for so this is the name of employee number two. I'm gonna copy this, go all the way here, boom, 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 copy this to here. Did that make a little bit more sense? Did that make sense? Perfect. Thank you. Yeah, ask me a question, guys. Now I gotta delete it. Oh, I can just do this. What am I doing? Okay, hopefully that cleared it up. Okay. Now the first thing we need to do is we need to create this list of employees, right? Just create the space, fill in nothing, just create the memory so we can start uh the list or the array with actual values, right? So first things first, we'll just call it EMP as an employee, and EMP refers to the struct name. EMP here refers to like this, right? It's called employee, but I'm just using abbreviations. EMP equals to malloc size of and employee, again employee, uh sorry, again I messed up like that. The EMP star new. Okay, now size of EMP times e count, which was passed to the function parameters. So in this line we have created this block of memory. Now we need to start filling in these values, right? So what I'm going to do is I'm going to run a for loop to this part, and then at each index I will copy the value. So it will be like for, let's just do it, for int I equals to 0, I is smaller than emp count, I plus plus, right? Because e count is the size of this array. Now again, let's do the easy part first so we build up some confidence. Let me turn off my fan. Okay, so the easy part is just filling in the salaries. So I'm just gonna say new arrow. It will be new arrow salaries. Oh, sorry, new arrow. Sorry, no, no, no. It would be new at the ith position. Arrow salary catches the same value from double. Oh, sorry, salaries at I. So we have filled in this part from here. Did I confuse anybody? This part always gets me. How do we know that we should be doing? Yeah, so okay. How I imagine this is like you use dot when you are at that position essentially. So, oh wait, what the okay, okay, my bad. Sorry guys. Sorry, sorry, sorry. Okay, I messed up. I messed up. Okay, okay. So it'd be new I dot salaries catches the value from salaries at the ith position. So when okay, let me draw this. Boom, boom. Okay, at the very start, so the indexes are 0, 1, 2. My I index, or sorry, my I value, my loop starts from 0, right? So my I is here, right? I am currently pointing to this box. I am currently at this box, so I can fill in the salary part, right? Now this is the string type. This is again pointing to another box, right? So I'm gonna use dot, so it would be like I dot arrow kind of thingy, right? So if I'm at that box, I can use I, right? But if I wanna go to this box, I will use like I arrow. Did that make sense? Just like it, so it like dereferences. It's another method of like dereferencing. It would arrow would go to like this box. So it would go I. So if I do I arrow, it would go to this box. Yeah, that's what we want. Yeah. Yeah, but for the salary, we don't need to do that because salary is just in this position, right? Salary is not pointing to another struct. Salary is a part of this employee, but the string type is a pointing to another struct. So we will use to go there. I will use an arrow, right? Since okay, salary is part of this struct, I will use dot. If a isn't yeah if a data is part, like, so for example, salary is part of this box, this is also part of this box, but it is essentially pointing to another struct, right? So now I want to kind of use arrow. Did that clear it up? Perfect. And let's just delete this. So okay, the easy part is done. Now, like, for the difficult part is I want to so I've created this memory, right? Now I want to dereference this and create this memory. So for that, it would be just new at the ith position dot ename equals to malloc size of string type. Let's just call it st as in string type. So in this line, I have created this box. Okay, my drawing is like just getting worse and worse, but hopefully you understand. Uh, So I'm going to this position, right? And then referencing this and then creating this box. So I've now, so the dot, so the dot is referencing to this position or like this member, and then it's telling like, hey, create the box here, create the new memory for the string type struct. Now now to access the created memory for string type, I have to go there, right? I have to be physically present in that box. So now I will use my arrow. Like, hey, go there. Like, I have created this memory. Now go there kind of thingy. Like arrow as in like go there. You know what I'm saying? Yeah, yeah, yeah. Hopefully it does. Hopefully it does. Because this question, if you understand this question and you can like visualize this, bro, I'm telling you, you will be like the DMA part is gonna like start clicking more and more. Because I would say DMA is like the on the harder side of things for CS1. So yeah, and this is like important stuff, man. Like once you understand the memory, the how memory is you referenced and blah blah blah, like Python will be child's play. I'm not kidding. Now I code in Python. I am so glad that I learned C because Python is like child's play. Anyways, I'm going off topic, but hopefully that you guys understood that. Uh, Now I've created this box, or well, now I have created it. Now I'm gonna dereference it and go to that position and fill in the name and then fill in the length part, right? So that's just that. So new at the ith position dot ename. Sorry, give me 1 second. Ename arrow name, right? So this is the part where like new at the I position dot ename arrow. So like it's just saying like this is position I, right? And this is new. So ename, so it's just saying new at I position, right? So now it is here. Now arrow to this box. Did that make sense? Hopefully, I think that one is like that one should really click. Because that one clicked for me too. Yeah, yeah, perfect, perfect. I'm just gonna keep that diagram because I think that one is important. Or I'll redraw it. I'll redraw it. How about this? I'll redraw it after like solving the question. Uh, okay. New at the I position dot accessing ename arrow because ename arrow name is pointing to another struct. So I'm going to the name field, and once I go to the name field, I need to allocate more space for the string, right? So I'll just do malloc size of char times 50 or something. Oh, sorry, length. Wait, where is length? Oh, we need to calculate the length. Sorry. Oh my goodness. Okay, first we need to calculate the length of the string, like int length equal to str length of n at I, which is just this, and at that position. Now I have length. I can just call it new at the I position, accessing the ename field, then dereferencing the name field that is pointing to by the ename equals to malloc size of char plus one, or sorry, size of character times length, and then plus one for the null terminator. Did that make sense? So now I've created a memory for the name, and I'm just gonna call in my string copy function, strcpy. Again, destination is new at the ith position dot ename, and what I want to copy is n from I, right? And then for the length part, wait, what's above length? This part? This? This is this. Because I need to calculate the length first, right? Of the string. So to calculate that much space. To allocate that much space. Did that make sense? Okay, yeah, don't worry, guys. You can ask me a billion questions on this because I really want to like after this session, I really want you to guys like, like understand it. Uh, so I keep asking me questions. That's good. Uh, Now I have now we just once I created this space, now I'm gonna string copy it, and now I want to fill in the length part, right? So length part I already calculated. I can just fill it. So I can just say new at the ith position dot uh ename arrow length catches the same value as length, and it will, and since it's a for loop, it will keep doing it until it reaches the end part. Okay. Questions? Well, let me draw the diagram thing, right? So let's say we have this, we have the box, and then this is pointed to by new, and we have our ename, which is just like a of type st, right? So we have a st ename. This is the data part, and then we have double salary. So this part everyone understood. So what I want to do is I want to go new at the ith position dot ename, right? So now what this does is it will like go here, right? Now, since this also points to another struct, I want to use my arrow to access it. Name. And it has two fields, name and then length, right? So to access the name, I will use arrow. So new at the ith position dot ename accesses this box. And then since I want to dereference to here, I will use arrow and then I will specify which member I want to access. So I want to access the name member. Any questions on that one so far? That one is like I mean, this is a 10-point question. It is meant to be hard because in the FE they make you like, they want to like make you like ponder, if you will. Uh yeah. So you guys want me to move on or do you have any questions? Please let me know. Okay, I'm just can you scroll up a bit uh here? Yeah, this plus one is just for the node terminator. Yeah. It should be, I mean, after we're done, Zoom will send me the link to the recording by like, so it should be up by tonight for sure. Yeah. Any questions on that one, Lorena? Did we have to do a for loop at some point? Yes, here to loop through this array. Yeah. All right. Again, this is I mean, I don't expect you to guys. Well, I kind of. Well, I'm gonna lie. I kind of expected to you guys like understand it in this recording, but again, now I remember when I took this class, I didn't understand this question the first try. You will understand it if you code it up. Like if you try, sit down, write it down. First time you'll be wrong. Second time you'll be wrong. Third time you'll be wrong. Fourth time you might just get it down. You know what I'm saying? Just write until you really nail the problem. That's what I did, and it worked. So hopefully everything's clear. Just gonna move on to the next question. This one's pretty easy. I'll give you guys a couple of seconds to read it. I just in I just in well I just wanted to go over this question because when I took the midterm, I kind of overlooked the freeing part, and my midterm had a question for the free, and then I completely messed it up. So I included one question for freeing memory. So take a couple of seconds, read it, and let me know when you're done. Okay, does anyone need more time to read the question or Is everyone good to go? Let me know. Everyone good to go or good? All right, perfect. I'm just gonna explain it conceptually and then we'll do the coding part. First things first is, okay, let me explain. So let's say we have a library, right? A library will have a collection of books. So it will have an array of books essentially, right? So let's say we have this many books of, like I said, let's do this, right? And the size of this is number of books, which is provided in the function parameter. So this library has four fields. It has sentences, as in, so each block or each index represents a book, right? This is the library pointing to the array of books, and each index is representing one book, right? A book will have sentences. Uh, how many sentences we have, number of sentences. It will have the name, the title of the book, and the author name, right? That's pretty straightforward. Like, right? It would have sentences. It would have how many sentences this book have, the title, and the author's name, right? Our task is to that we have been passed a so let's just do this. So our task is that we have been passed to the function a library, and our task is to, like, this library went out of business, and we need to like free all the memory, and so we can build something else there, right? So let's just do this. Void clean. It will take a library, right? It will take a book star. Let's just call it lib, and then int nb, as in the number of books this library has, right? So first things first, since this is just a single pointer type thing, let's just start with the easy part first, right? So I know, so whoa, what happened? Okay, never mind. I don't know what happened. All right. So the easy part is just like freeing this space since it's just a double pointer thing. So let me draw this out a little bit better. So let's say we have a book, right? It has our sentences. It has our number of sentences. It has a title, which is just a single pointer, and then it has an author name, which is also a single pointer. So this is just a character array. This is just a character array. C, 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 C. This will point to a array of pointers of type characters, right? So this is pointers, and the type of this pointer is a character pointer, and this in turn will point to a array of characters. Did that clear up? Like how this looks essentially? Wait, how come? Hopefully it did. Can you guys hear me? Okay. Did that clear it up? Hopefully it did. Okay, okay, perfect. So what we want to do is, so for freeing this, it's pretty simple. If I free this memory, I lose all this. If I free this memory, I lose all this. But the tricky part is freeing this one, right? We need to free this. We need to free this. We need to free this. Then we need to free this, free this, free this. Or sorry, like free this, then free this, free this, then free this, free this, then free this. So that's how like conceptually it will look like. So now let me redo the, so void clean, it takes in a book star lib, which is just an array of books, and then it would take int nb as in the number of book this library has. So I will run a loop on this array, then dereference everything, and then remove the memory, right? So let's just do the easy part first, which is just free uh title, sorry, free sorry, free library at the ith position dot title, right? Going to the ith position, referencing this, and then freeing it. Free lib at the ith position dot author. All right, so now I have freed this memory. Now for this, I will essentially run a nested kind of loop, right? So let's just call it for, uh, oh, I didn't even run a loop. Sorry, for int I equals to 0. I is smaller than the number of books, I plus plus. And then we're going to each and every index in that loop and then freeing the memory, right? Now for the double pointer to sentences, it would be just for j equals to 0. J is smaller than the number of sentences, so it would be lib at the ith position dot sentences. Oh, sorry, number of sentences, j plus plus, and then free uh library at the ith position dot uh sentences at the jth position. And then after that, we can just free library at the ith position dot sentences. And the reason, okay, the reason I'm using dot or a nested loop is because we have sentences is like it's an array of pointers itself, right? If it was just one block of memory, I could dereference it. Since it's not, I need to like go to each and every box, right? So I need to go here, I need to go here, I need to go here. So that's why I'm using the dot thing or the dot operator, if you will. Did that make sense? Any questions on that one? That again is a little bit complicated thingy, but I hope that cleared up a lot of like confusion. Yeah, this one's not too bad. This one's not too bad. That the employee one, that is like a tough question. But again, if you understand that one, you're good to go. Can I see the bottom of the code? Hopefully my iPad does not die. Okay. Anyone have any questions on that one or so far or no? So that's like the DMA. We have done the DMA, hopefully. Yeah, expect the midterm to be, I don't know, if you're a student for Dr. Haman, expect the midterm to be like harder than the quizzes, but I'm not sure for Dr. Ali because I haven't looked the quizzes for Dr. Ali. But are the quizzes for Dr. Is Matthew still here? Are the quizzes for Dr. Ali like if you were to compare these questions to the quiz for Dr. Ali, how would you rate them? Like is it harder? Is it easier? Is it like medium? Oh, okay, okay, okay. But yeah, hopefully this is you're able to understand this part. So we're officially done with the annoying DMA. You pat yourself in the back. Yeah, again, thing is like, I'll be very honest. I can explain it to you. I can explain, but you will only understand by doing. It's like you go to the gym, right? You can watch a billion videos on how to lift, but you're not gonna build any muscle unless you go to the gym and hit some weights. You know what I'm saying? So it's the same logic here. You kind of have to like get your hand dirty, like write some code, like you're gonna mess up, obviously. Like no one's a genius unless your IQ is already pretty good. But yeah, so you're gonna have to get your hands dirty and like write until it just clicks. So yeah, that's one advice. Okay, now what I'm gonna do is, where are my notes? No, this. All right. Okay, now let's begin to the linked list part. And also, I want to just showcase, I want to flex a little bit. This is all the practice I did when I took this class. This is literally for um, CS1 when I took this class. It's like most of the notes are for CS1. So kind of get your hands dirty. Yeah. Who did you? Dr. Ahmed. Yeah. But I mean, I love the quizzes, dude. This was my favorite class without a doubt. Out of everything I've taken at UCF, this one by far my favorite class without a doubt. I'm yapping, but whatever. All right, same thing. Now we just begin to link list. I'll give you guys, this is like a follow the code kind of thing. Give you guys a couple of minutes. When you're done, let me know. Oh, also, you can take a picture if you want. You can like take a picture and put it to the side. So that way when I'm like writing or like it's easier for you to like connect the dots when I'm like writing the how it will look like. All right, so hopefully everyone read the question or like took a picture to the side. I'm just gonna like jump straight into it. Uh, okay. So our list is my goodness. So given list is 6, 8, 4, 7. Oh my goodness, I forgot. Oh my goodness. Oh my God. I had to talk about Calic. Oh my God, I forgot. I had to talk about Calic a little bit. Okay, let's do this question. Do you guys still want to do DMA or are you just like done? Like my brain is kind of fried with DMA, honestly. Oh shit. Okay. We have to do Calic now because Dr. Ali told me to do it. Okay. I'm gonna do Calic. Let's just do this question first and I'll do Calic. Okay, how about this? That sound good? Perfect. And then N means here null, okay? So let's do this. So we go to the function and then it says the function would be called with the head of the linked list, which is this, and the second parameter would be 3. Okay? So uh, let's do the first iteration, right? This is iteration number 1. So it just says for int I equal to 0, I is smaller than 3. So 0 is smaller than 3. Plus plus I doesn't really matter in this scenario. We will create a current node, which will be at the same position as the head, right? Then what we'll do for this, current will travel all the way till the end of the linked list. So it says while cur arrow next does not equals to null, cur equal to cur arrow next, right? So we'll just do boom, 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 and then cur will end here, and then our while loop will exit, okay? Now it says cur arrow next is equals to head. So the cur arrow next will point back to the head, right? Then cur equals to cur arrow next. So the pointer cur will, instead of going here, will again reach back my head, right? Then it says head equals to head arrow next, right? So head arrow, so head goes from here to here. Then it says cur arrow next, which is this. Now pointing, instead of pointing to 8, points to null, right? So after this iteration, our linked list should look like something like, so our head is 8, 4, 7, 5, 6. And this is null. So after the first iteration, our linked list should look like this. Now, our since k was passed in as 3, now my head is here, right? And then k becomes 1, which is, sorry, I becomes 1, which is less than 3. So we will repeat the whole process. We will create a current node, which is at the same place as the head, traverse, 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 traverse until the next node is a null node. Current comes here. Then after exiting the while loop, we say current arrow next points back to the head, right? Then what it says, current arrow next points back to the head, and then cur equals to cur arrow next. So from here, it goes back to where the head was. Then our head tracker from here goes to head equals to head arrow next. So head goes here. Now it says cur arrow next. So this, instead of pointing to 4, will now point to null. So after this iteration, our list should look like 4, 7, 5, 6, and then 8. And this is null. So this is after second iteration. Now 0, 1, 2, right? So 2 is again smaller than 3 because that's our for loop, right? For int I equal to 0, I is smaller than k, keep doing these steps, right? So our I is smaller than 3, which is 2, we will repeat the same process, right? Head is here, cur is here, cur again travels to the very ending node. Then cur, we say cur is here, right? So cur instead comes here, and we say cur arrow next points to the head. So cur comes back here again. Then we say head equals to head arrow next, right? And then cur arrow next points to null, right? So finally, our list should look something like 7, 5, 6, 8, and then 4. Yeah, this is our final answer. So that one is pretty simple. That one's like not, well, not simple, sorry. But it's like if you follow it step by step, it becomes very simple. If you follow it to, like, you look at the code for each iteration, it becomes very obvious, right? So that's what I did. I just like follow. Seems, yeah, drawing helps a lot. You like, that's why they so in the FE, okay, let me scroll up a bit. I kind of like when I was taking the picture of this for my iPad, I took the small, I cut the paper down, but in the FE you will have all this extra space. Okay, now I'm just going to record a small video of differentiating between malloc and calloc. They're both essentially allocate space, but there are two differences between malloc and calloc. So first one, let's say we have an dynamic, we have a pointer, right? And then we want to assign this pointer the starting address of the allocated memory. So I will call in malloc, and we will do size of an int, right? So malloc takes in one argument, which is how many bytes of memory you want, right? So in this case, I want just 4 bytes of memory because size of an integer is just 4. So malloc just only takes in one argument, and this is like how much memory you want to create essentially, right? But calloc, on the other hand, let's just do int star b equals to calloc. Calloc, on the other hand, takes in 2 arguments, right? It will take in how many elements do you want. So for example, if I'm creating a memory for an array, it will ask me like, hey, how many elements do you want, right? So for example, I want my array to have 10 elements, so I will put in 10 here, And then the second element would be how, and the second argument would be how many, what would be the size of each element. Since it's an integer array, the size of integer is just 4, so I can just do size of int, right? So that's like the first difference. First takes in one argument, takes in two arguments. That's the first difference. The second and the biggest difference is malloc will create space, but it will create space and fill the created space with some garbage values, right? Because it's not usable values. It would just fill it with some like garbage values that you can't access, or it just doesn't make any sense, right? So malloc, it would create an array, let's say of size this, and each value here would be just like garbage, right? You cannot make sense of these values, they're just garbage. But calloc, on the other hand, when it creates memory, it will clear everything, and it will initialize everything to 0. And this way you can use this and you can use calloc for a very popular technique which is called of hashing, uh, which is very useful in many questions for like lead code and all that kind of stuff. And this is a popular technique. So that these are the two main differences between malloc and calloc. Okay, now I'm just gonna go over question number 2 for the linked list. This is a I'm just continuing the recording of the questions that I wasn't able to cover in the Zoom meeting. So just I would recommend that you guys pause this video, read the question by yourself, and then unpause the video, and then I will try to explain the question conceptually, and then we will solve it. Okay, so the question essentially means that you are given a linked list that stores an integer in reverse order. So for example, if the integer was 231, the linked list will store the integer in a reverse order, meaning it will store the integer as 1, 2, 3, and this would be null, right? So we're given two linked lists that store integers in this way. What we want to do is we want to compare these two linked lists and return whichever is the biggest value, right? If they're equivalent, if both of the linked lists are equivalent as in their integer value is equivalent, we want to return 0. Otherwise, it says if blah, 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 if okay, wait, using the node struct below, write recursive function compared to function takes in. Okay, yeah. So we want to return a negative number if num1 is smaller. Otherwise, we want to return a positive integer if num2 is bigger. I was just verifying because I think I had it the other way around. So hopefully you understand. So given two linked lists, right? So 2, let's say 3, 1, and another linked list, let's say 2, 3, 3. This is n1, this is n2. We would return -1 in this case, since n1 is smaller than n2. And if we would like switch around, we need to return 1, and if they're equivalent, we need to return 0. So with that being said, the one way to solve this is to recursively just travel to the end nodes of each of the linked list and then compare these two nodes, because as you can see, since they're in the reverse order, the most significant digit of these linked lists would be at the very end, right? So for example, what I mean by that is if we have an integer 2, 3, 1, and I changed 2 to 3, the number would change drastically, right? It would change by 100 integers essentially. So this is our most significant number in the integer, right? And and 1 here would be the least significant. If I were to change 1 to 2, I just did a +1, right? As you can see, I did a +1 here, but the number changed drastically. So this is our most significant bit. So that's what we're gonna do. Like we're gonna traverse recursively all the way to this point, right? And then compare these two nodes, or as in like so we can just subtract these two nodes. So if we do 1 minus 3, it will return the value of -2, and we want to return -2 if n1 is smaller, right? So we can just like subtract these two values. So we can subtract n1 minus n2, so that way we get the result. But one way to do this is let me just code it up, and we'll do the base cases and so forth. Okay, so hopefully everyone understood that conceptually. Now just write the function int, let's call it compare to, takes in node star n1 and node star n2, right? These are the two heads of the linked list. We can, first things first, if n1 equals to null, right, and n2 also is equals to null, I want to return 0. And why is that? Think of this. Let's say the node 1 passed, n1 passed to the function, and n2 the passed to the function were essentially null, right? They were both null, they were not initialized. That means there's nothing to compare, right? So I return 0. That's one case. Another case is I have essentially traversed through the whole array, right? And I have reached the very end point, right? So that means that these two lists are of the same size, and we would need to like subtract these two values, right? So that's another case. Okay. Another case would be if n1 becomes null before n2, we return -1, right? That means if I have traversed the endpoint of n1 before n2, I want to return null. An example of that would be, let me just write out the base cases first. So if n2 ever becomes null before n1, we want to return 1, right? A positive integer. So an example of this would be like, let's say our linked lists are 2, 3, right? This is n1, and our n2 is 3, 1, 1, right? So what would happen is we would traverse here, we would traverse here, we would traverse here. N1 is now null, right? So I want to return -1 since the size of this array, or well, size of this linked list is smaller. So obviously, since the digits are, well, not the digits. If the size is smaller, the digit is always less than n2, right? So we want to just immediately return -1, right? Perfect. So hopefully that makes sense. Now we want to call the function and traverse, and we will not. So we would have to make a temp variable for that. We would do int t equals to the function call of c2 n1 arrow next, comma n2 arrow next. And the reason why we're doing that is because why we're creating a temp variable, because think of a base case. Let's take this. Oh, sorry. I'm gonna draw another diagram. So like think of this like 2, 3, 1, right? And then 2, 4, 1, right? So what would happen is temp would make this call, 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 make this call, make this call. Now they are n1 and n2 are both null, and we return 0 to temp. So temp catches the value of 0, not the function, okay? Not the function, okay? So hopefully that clears it up. And temp now catches the value of 0, and then since both of these lengths are same, we need to check, we need to subtract number 1 digit from number 2 digit, right? So we will add our case for that. Let me just delete all this. So we will add our case for that. So it would be just if my t variable ever becomes 0, that means that the length of the both of the linked lists are same. We want to subtract n1 from n2. So we just do return n1 arrow digit minus n2 arrow digit. And this would essentially, the return value of this would ensure that whichever list is smaller, we are returning a negative integer, right? So for example, if we do 1 minus 2, it will return -1, right? So that would mean that list node 1 linked list is smaller than that. And the opposite of that would be if t does not equal to 0, we just return t. Pretty simple, because t is the one who is making the function calls, and if at any point n2 becomes null, let's assume that n2 is smaller than n1, this return value gets returned to this, not to the function itself, returned to this, and this catches, and then we are finally able to return t all the way to my Wow, this is a long piece of code, huh? All the way to my function, right? So let's do a couple of I'm gonna do one example. I'm gonna do a couple of examples so you better understand, because this problem can be a little tough to like visualize sometimes. So let's do an example of, let's do example one. Let's call it example one. Lists are 2, 3, and then 1. This would be 3, 3, and then 1. Okay, this is n1, this is n2. Okay, now t is making the function call. T is going here, t is going here. Or sorry, the t is making the function call, n2 are going here, but t is the one who's making the function call. Again, n1 is going here, then going here, then going here, then going here. At some point, they're both n1 and n2 are both equal to 0. Now t catches the value, sorry. Now t catches the value of 0, as you can see in my piece of code here. If t ever becomes 0, sorry, here, return 0 to t, right? Return 0 to t. And if t ever becomes 0, that means that the length of these two linked lists are similar. What we want to do is we want to subtract n1 digit, which would be this digit minus this digit. So it would be 1 minus 1. Again, t catches the value of 0. So we go back, we pop our stack, because recursion is like a function call in the stack, right? It keeps building up, building up, building up until we reach the base case, and then it keeps popping, right? And then it pops, pops, pops. So we essentially now we go back, right? So we do, again, we do 3 minus 3, which is 0 again. So we have to, since t is again 0, we go back to the last caller again, which was t, and then we finally do 2 minus 3, which is negative 1, and then it gets returned to t, and then we return, since t is not now 0, so now t does not equals to 0, we return t to the function. So hopefully that cleared it up. You can always ask questions in my office hours, or just comment them down below so I'm able to better help you. Now for question number 3, let's see what it is. Again, I will recommend, oh, this is a good question. I would recommend that you pause the video and then read it, and then yeah. So again, hopefully you have paused and read it on your own time. So it's just asking us, like, given a singly linked list, what we need to do is we need to move the head of the list to near to the tail, and it is guaranteed that the elements, there will be at least 3 elements. So for example, we are given an example 1752. After the operation, as you can see, our head is now closer to the end of the linked list, right? So for example, let's say we had a link, oh, that's just perfect, isn't it? Okay, so for example, if our linked list was 2, 3, 1, right? Initially, after the operation, after the function, it should look something like 3, 2, 1, right? We're moving head to here, right? We are moving head closer to the ending node. So for this, we are also guaranteed that the linked list will never be null, because there will always be 3 nodes in the linked list, right? So to code this up, what we'll do is, let's another diagram. I love to draw diagrams, guys. Anyways, 1, 2, 3, 4. What we need to do is we need to traverse all the way to the second last node and then make the connection, right? So we need to traverse all the way to the second last node, then our new head, so this is our old head, then our new head will be this, and then we will make the connection. We'll say head arrow next points to the next node, and then this points to this. So after the operation, our linked list should look like 2, 3, 1, 4, null. Okay, so now let's just do it. Node, I'm just going to use abbreviations, but in the FE, just make sure that you are using the whole names. So I'm just going to call it move, takes in a pointer to the head, right? So we don't need to add a base case to check if the head is already null, because we're guaranteed there will be 3 nodes, right? So first thing is first, I will create a traversal node. So let's just call it node star t is equals to head. That's the first part. Now what I'll do is while t arrow next, right? Because we want to traverse to the second last node. does not equals to null, t equals to t arrow next, right? Go to the next index or place, sorry. So after some point, it would reach the second last node. Then what we want to do is we want to move, or we want to first thing is first, we want to move, we want to create our new head, right? So we'll call node star new edge is equals to head arrow next, right? Because that this is will be our new head. This will be our starting point for the for our new linked list, right? Once we have done that, now we can say head arrow next is pointing to the same place as t arrow next, right? And then we can say t arrow next points to the same place as head. So this is the part. So this is the part we're making the connection. This is the part where we are assigning the new head, right? And then after last and least, we return our new head back to the function. So hopefully that clears it up. It's pretty straightforward, honestly. If you do a couple of dry runs, if you try writing the code a couple of times on your own, it will start to click a little bit better. So I would highly suggest that you do a couple of diagrams on your own. That's how I learned the best, and I would highly recommend that you do the same. Okay, now let's move to the question. All right, so now let's jump to the question number 4 of linked list. Hopefully you have paused. You can pause the video and read the question for yourself, and then I'll try to explain the question in my own words. Okay, so what the question is essentially telling us that we have to write a function called delete me, which takes in two parameters. The first one being the head of the doubly linked list, the second one being a pointer to the node that we want to delete, and it is called me, right? So for example, we have this list, linked list, I mean, which is a doubly linked list, something like this, and we are given the head, and let's just assume that the me pointer is somewhere in the middle. What we want to do is we want to delete this, right? This is our target, and we want to delete this. So one way to do this is by making this connection, right? We can say head arrow next is equals to uh, head arrow next is equals to me arrow next. So that way we make this connection, and then we can say me arrow next arrow priv equals to head, something like this, right? So, and also that's like the one case we have to check for. Another case that we have to check for if is again, in one case we have to check for is if me is essentially at the same position as the head. If it is, we can just say if me is at the same position as head, we can just move head by one, and then we can just like free our me pointer, right? So hopefully you were able to understand. When I code it up, I'll do one more example, but let me code it up first, right? So it'd be like node star delete takes in the head, let's just call it edge, and takes in a pointer called me. This is pointer that is pointing to a valid node in our link in our doubly linked list. So first thing is first, we need to check if head is equals to me, right? If they're at pointing to the same node, what we want to do is we want to say head is equals to head arrow next. Just increment, just the head goes to the next place, right? Now we want to check if me arrow prev does not equals to null. Sorry. Meaning the previous pointer of this me node is pointing to a valid node in our linked list. What we want to do is we want to make the connection to the next node. So we can just say me arrow prev. It would go, now this part will go to the previous node, or well, dereference to the previous node. Now that we're in the previous node, I will dereference to the next part, right? So me arrow prev arrow next catches or is pointing to me arrow next, right? This is the part where we're doing this. Let's say this is our me and this is our previous node, which is a valid node. We're saying me arrow prev at this position. Now me is like we are at this position, so we're dereferencing it, and then we're saying next, right? Instead of pointing to me, point to me arrow next. In this case, it is null, so yeah. So hopefully you were able to understand that. And then again, we need to check if me arrow next not null. We have to say me arrow next, go to the next node, arrow prev, right? Go to the next node and then dereference the prev pointer to be the same place as me arrow prev. And lastly, we can just free the node which is called me, right? So hopefully you were able to understand. Please leave a comment if you have any issues understanding that one. Okay, so hopefully everyone was able to understand the DMA, the linked list part of this video. Now I'm just gonna jump to the stack part of this video. This is honestly like, this should be, if you're like, if you have trouble understanding code, this should be like free points for you. So this, because this doesn't really involve any coding. So the question is pretty simple. Given an infix expression, the following infix impression to postfix using a stack, right? So given an infix, convert it to a postfix. So pretty simple. I'm just gonna go over the question, and that way you're able to understand the question itself, right? So anytime I see a variable, I push it to my postfix, right? I push it to my resultant postfix expression. So for example, I see 9, I just push it over here. Sorry. I push it over here. I see an operator, as in a multiply sign, a plus, division, mod, blah, blah, blah. I push it to my stack, right? I push it to my stack. And also a tip is like, whenever you're doing it, I would recommend that you work the side space as a rough space. And then that way you're like your stack doesn't look like all like weird, right? So that way you're able to like make much more sense of your stack. So that's how I do it. So anyways, I see a multiply sign, I just push it to my stack. Now see I 2, now I see a 2, I push it to my expression. Now I see a plus sign which has a lower precedence than my multiply sign. So what I will do is I will pop my my multiply sign and push it down, right? And then push my plus sign over to my stack. Now I see a 4, it goes here. Now I see a negative, which has the same precedence as the plus sign. So what I will do is I will pop it here and then push my negative here, right? Now I see a 3, it goes down. Now I see a division sign, which has a higher precedence, so it goes to my stack, right? So after the stack A, after like before the expression A, our stack should look something like a negative and a division sign. Once I've done that, I'm just gonna copy my stack over to the side as a rough work. Okay, now couple of important thing. If you see an opening parentheses, it just goes to my stack, right? A closing parentheses will never go to your stack. An opening parentheses will always go to your stack, right? Not the closing one. So I see a opening parentheses, I push it to my stack. Now I see a 6, I push it here, I put it here. Now I see a multiply, I put it here. I see a 4, I put it here. Now I see another opening parentheses, I just put it here. Now I see a minus, I put it here. Now I see a 3, I put it down. Now I see my first closing parentheses, right? So what I'll do is I will pop until I find the matching one, right? So I will keep popping until I find my opening parentheses, right? So I'll pop, and now I see my closing opening parentheses. I'll cancel this. My negative goes here. Now again, I see my closing parentheses. I will pop, push it here. Now I see a plus sign, which is of a lower precedence than my division and the same precedence as my negative sign. So these both come down, right? And then my plus is over here. Then I see a 1. Then I see a multiply, which is of higher precedence. So it goes to my stack. So after all this, my stack should look like this. Now again, I'm just going to copy it over here. Now I see a opening, I put it here. I see a 7, I put it here. A minus, put it here. 4, here. closing pop, 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 minus goes here. Now I see a division which is of the same presence as the multiply. So this pops and goes here. Now I see a opening parentheses, I put it here. I see a 5, I put it here. I see a plus, I put it here. I see a 6. Now I see my closing parentheses. It'll be boom, boom, boom. Keep popping it. And it will be just plus. And then since I've ran out of space, it will be just this and this. And our final stack was this. So hopefully this is clear. It's pretty straightforward. If you do a couple of if you solve a couple of questions like this, it just becomes very easy. It becomes very intuitive. So hopefully that was clear. Now let's solve the question number 2 of stack. This is again a pretty straightforward question. Yeah, so what we'll do is we need to just essentially follow the stack right from the beginning, and it just gives us like where is A, where is B, and where is C. So let's just follow our stack, right? So first things first, it tells me to push the value of 12. I put it here. Sorry, let's do it again. Let's put it here, right on the side. Now it says push 5. I put it here. Now I push -8. Put it here. Now I pop my stack, right? So I will pop -8. I will pop 5. And now it says push 23. So I'll push 23. And then this is my first stop, right? So my stack after the first stop would look like 12 and 23, right? Now I will just copy 12 and 23 to the side and then keep following. Now it says pop my stack, so I will remove 23. Then it says push 17. This goes here. Push -3, and then it says pop and pop. So 12 is here. Now it says push 9, put it here. Push 6, put it here. Push 14, -14, here. Now it says pop, pop. Oh, sorry, I didn't even stop. My bad. Let's just redo it. Okay, never mind. So after the end of our A expression, it will look something like 12 and 23. Now what I want to do is I want to pop 23. So I will pop 23, push 17, and then push -3. Now it says pop 2 times, so I will remove -3 and 17. Now it says to push 9. Alright, so now I'm going to record the video for the Q question. Again, I will recommend that you pause the video, read it yourself, and now I'm going to explain the question conceptually. So what the question is even asking us, we are being given a linked list implementation of a queue. And what we need to do is, so as you can see, a node has 3 fields in this case: a character name, an HP field, and a pointer to the next variable, right? So this is a player node. It has a name, it has an HP, and then it has a pointer to the next node, essentially. So that's how it looks like. So what our task is, we are designing this game and we are writing the function where we are battling the first 2 players in the queue, right? Once we battle them, our task is to check whoever has the most HP between player 1 and player 2, which is like the first 2 players inside the queue. So this would be player 1, player 2. Whoever has the most HP, they get added back to the queue. So for example, the queue looks something like this, right? If player 2 has more HP, they get, so I DQ, then I check whoever has the most HP. So for example, in this case, let's say 1 has more HP than player 2, right? They get added back to my queue, right? So our queue should look something like this again. And this was like player 3, and this is player 1 back here, right? So that's like the whole idea of the question that we have to do. And at any point, it also mentions that at any point when we DQ the first 2 players within the queue, and if they happen to have the same amount of HP, the player 2 gets appended back to my queue, right? So that's another thing we have to look out for. And it also says the game will go on till the size of the queue is bigger than 1, because at any point the size is just 1, right?
because at any point the size of the queue is 1, that means I only have one player left in the queue and they will be our winner, right? So hopefully that explanation cleared up. Now let me do the coding part for it. So we just void, I'm just gonna call it battle game as in BG, and then I'm just gonna call it Q star, and then it takes a pointer to a game queue. I'm using abbreviations just to like save some space, but obviously when you're in the FE, write all the whole names, right? So now the first things first, I want to keep doing it until my size of the queue is bigger than 1, right? Because at any point it goes smaller than 1, I only have one player left, and they are essentially the winner of the game, right? So I'm just gonna write this. While the size of the game queue is bigger than 1, and also these functions are provided to you in the question. So for example, enqueue, integer size, dequeue, front, delete player, they're already provided to you in the function, so you don't have to write them by scratch, right? So first things first, while the size of the queue is bigger than 1, I want to dequeue the very first two players, right? So I'll create a a a a temp variable to hold the dequeued value of player 1, right? So bq, let's call it p1, is equals to dq, catches the value of dq from my game queue, right? So it would dq the first player, and then p1, player 1 is the value, uh is being player 1 holds the value of the dq'd from the queue, right? So it's the very first player in our queue. Now I again create another pointer, let's call it p2 as in player 2, and I dq the value again. This dq like essentially removes the whole player from the queue, right? They're no longer in the queue. And now once I have these two variables that essentially hold the first two players of the queue, I'm gonna check whichever player has the highest HP, right? So I'm just gonna say if P1 arrow HP, dereferencing the HP, is greater than P2 arrow HP, then I wanna enqueue back my player 1 back to the queue, right? So I'm just gonna call the enqueue function, and I'm gonna pass in the GQ where I want to enqueue and what I want to enqueue. So I want to enqueue P1 back, and then I will just delete player 2 since they were the loser of this game, right? That's pretty simple, right? Now we can write an else if block saying like if p2 arrow hp is bigger than p1 arrow hp, do the same thing, right? Enqueue p2 back and delete sorry, enqueue p2 back and delete p1. But in the question it says that if at any point that the HP are same or bigger, I can just enqueue P2 back, right? So I can just write the else statement, and this way this will handle both the cases of the HP of player 2 being higher than player 1, and it will also handle the edge case of the HP of player 2 being the same as player 1, right? So else NQ where GQ player 2 back to my queue, and then just delete player 1. Delete player 1. All right. After some point, like it will keep happening, and after some point, my queue will become the size of 1, right? And my while loop will exit now that I'm guaranteed that I have exactly one player left in my queue. So what I can do is I can just DQ that front player, right? So for example, after this, the size of my queue will be only 1, right? I will have only one node in my queue. What I can do is I can create a new variable called the winner of the game, and then DQ that value and just print out the person who won the game, right? So for example, it would be just player, uh, I called it P, right? So it'd be like player W as in player winner, or sorry, these are player pointers, guys. I'm sorry, I wrote on Q, but these are player pointers. So that would be like player, player pointer. Uh, Now I will have a player pointer. Let's call it win, as in the person who won. Then I will dequeue from the front, right? Or I will return the value from the front, which is just I think it's provided in the function. Yeah, returns pointer to the front node, as in like I only have one node, so I'll just return the front. I'll say front of GQ. After doing all this battle, I will only have one node left, and then I can just like printf the value, like printf who won, printf like %d or something, %s, and then the win arrow name. All right, so hopefully that was clear.